Welcome everyone to this last session of this long day, and I think you are pretty mad because this is a security one. Before we start, I would like to know if some people are using tools that help them to find and track the vulnerabilities in their dependencies. Okay, and in those people, who is not using NPM Audit? So nobody, and okay. What are you using? Okay, so that's great, that's the talk. And for the other person, who is developing Java application? Okay, so it's almost all the people there. So the thing is that if you are not trying to find out what's going on in your dependencies, you are currently facing a risk that is really well depicted by the scene of that movie, where you can find that quote. Do you know which movie I'm talking about? No? That's the Alien movie. Who have seen that movie? The first one. So this is the scene where you can see the crew eating around the table. And one of the guys is complaining about the food. And suddenly, it looks like he's suffering a lot, and nobody was understanding what's going on. And one of his friends, thinking he was making a joke, said to him, "The food ain't that bad, man." And suddenly, you have an alien embryo that just burst the chest of the guy. Remember that scene? So that's a bit pushy, but that's basically the risk that we are all facing today if we are not trying to find out what's going on in our application. Maybe we have vulnerabilities lurking in our application since several weeks, several months, several years. And one day, when it comes out, it might hurt a lot. So let's introduce myself. My name is Julien Topçu. I'm a lead dev at Société Générale, which is a French bank. And I'm also a member of the OWASP Foundation. Who knows OWASP? Okay. So that's a not-for-profit organization that define security best practices and also provide security tools that help us to strengthen the security of our application. And I know that most of the people there have never seen the face of one of those aliens, and this is what it looks like. So you should know that all publicly known vulnerabilities are gathered into a database, which is named the National Vulnerability Database, hosted by the US government. And in this database, you can find those vulnerabilities in the form of a report that follow one standard, which is named the Common Vulnerability and Exposure. That's why, usually, when you see some report statement of vulnerabilities, you have an ID that starts with CVE, with the date where the vulnerability has been found, and a sequence of number. Let me show you what it looks like. So that's basically one of the reports. Here we have the report of the Heartbleed vulnerability. Who knows Heartbleed? Okay, so as described here, it was a defect in the implementation of OpenSSL of the TLS protocol, and it hurt very badly. So in those reports, you have the CVID, a description of the vulnerability, an impact analysis, where you can find a score here that is defining the criticality of the vulnerability. But we will talk a bit about that later. You have a set of links where you can find more information on how to fix the problem. And at the end, you will have more information like the vulnerability type. You have to know that all the vulnerability types are also gathered in a dictionary, which is named the Common Weakness Enumeration. That's why here we have an ID that starts with CWE as well. If you click on that, you will land on another website that will explain you what kind of weakness you have that was exploited with this vulnerability. So there's a lot of information here, a lot of description, and sometimes you have some code example that's explaining you what is exactly this weakness and perhaps sometimes how to fix that. Okay, And what is really important in a CVE report is the list of the components that are impacted by the vulnerability. So here, you can see that this is OpenSSL since the version 1.1 until the version 1.2 beta 1. Okay. So the thing is, there's a lot of vulnerabilities. And if you take the little green guy, he may be really annoying, but not that dangerous, right? But Thanos here is a really bad guy. If he snaps his finger, half of the room will disappear. So how can we figure out the criticality of one vulnerability? So in security, we have our own Richter scale, which is named the Common Vulnerability Scoring System, named also CVSS. That is a calculator that will compute a score between 0 and 10. 10 is the highest level of criticality you can have. I will show you how it works. So when someone is finding a new vulnerability and is currently filling it inside the database, the NVD database, he's using that calculator that is hosted on the first.org website. Here you have all the criteria of your vulnerability. So you can say, for example, what is the attack vector? So it only needs to be over the internet to be exploited. Okay, great. Or not great, in fact. So attack complexity, is that complex to perform the attack? No, not at all. Let's imagine. Does it require privileges, meaning does it require to be authenticated with some kind of privileges to exploit the attack? None. Okay, fine. Does it require user integration, or it can be automated? Okay, no. No user interaction, sorry. The scope. So the scope is basically the fact that with that vulnerability, you are able to attack more than the software, which is the vector. So let's say that it changed the scope, so it means that it will attack more than just the vector point. Okay, so now the confidentiality. So it means that does the information that are disclosed are confidential or not? So yes, this is really, really confidential. Integrity means will the attacker tamper anything on your system? Yes, and pretty badly. Sorry. And at the end, will it change something regarding the availability of your system? So will it perform a DDoS attack or something like this? Okay, yes, very badly. And here we have the highest score. If I'm changing one of those parameters, you see that the score also change, right? Just to show you how it works, okay? So this is how, in security, we can appreciate the criticality of vulnerability. Here you can notice I'm using one Marvel character, and I would like to pay tribute to Stanley, who died yesterday. So, Hexagonal. Okay, so now we'll see the tools that are provided by OWASP to be able to detect and track the vulnerabilities in our system. So here we'll see Dependency Check and Dependency Track. Dependency Check exists in several forms, like Maven plugin, Gradle plugin, and some other stuff, a CLI. And here we'll see the Jenkins plugin. So what it does, it will analyze your application, all the dependencies that are embedded in your application, and will query the national vulnerability database to know if it has been reported on them vulnerabilities. It will compile a report that can be uploaded on SonarQube, and I think that everyone here knows SonarQube. Or you can also upload it on Dependency Track, which is a brand new security tool provided by OWASP. It really looks like Sonar, but is dedicated to vulnerability management, right? So what is really important here also that there are open source tools, so you can contribute on GitHub. Let's start with the demo. So this is Dependency Track. Okay, I won't talk much about that page. We'll go directly to the projects page here. So here we have the list of the analyzed application in our continuous security pipeline. For each of them, we have a sum up of the potential vulnerabilities that has been reported in the National Vulnerability Database on the right. In the red, you have the critical one, and in green, you have the lowest one. Okay? So let's click on one of them. So we have here a dependencies tab, which lists all the dependencies of your application. And for each of them, you have the version, which is used in your application, and the potential vulnerability as well, which has been reported. Okay? What you can notice here is that DependencyTrack has detected that it was actually a Maven project. So it has queried the Maven Central repository to know if it exists newer version of your dependencies. If so, it will display a little yellow warning saying that, okay, I find something newer for your dependency. Why? Because the oldest your dependency is, the highest is the risk to have documented vulnerability on them. Okay? So let's move to the audit part. In the audit part, you have all the potential vulnerabilities with the impacted component, the version which is used in your application, the CVID again, the CWE, which is, remember, the vulnerability type and its severity. And it's not because something has been found here that you are actually affected by the vulnerability, okay? So let me show you. If you click on the first vulnerability here, we have a description, which is exactly what you can find in the National Vulnerability Database. Here it says that with the version of Spring Boot, which is embedded in my application, an attacker can craft a JSON patch request to execute arbitrary Java code, okay? The thing is that the attack vector here is Spring Data REST, and I'm not using that in my application. Okay? So I can say to DependencyTrack, okay, I'm not affected at all. And I can click also on suppress, so it won't be taken into account in the future analysis. That's basically something you can't do with NPM audit, right? To flag something as not affected or false positive. Okay, that was an easy one. So let's move to this one, which is a bit trickier. Here it says that with the version of JSON data format XML I'm using, with the XML mapper, I can be vulnerable to an XML external entity. Who knows what is it? Okay, really few people. Who is using XML? Okay, a bit more. So I will show you. I have my application running background. This is a pretty simple application, which has only one endpoint named transfer. So it's big enough. So the aim is to transfer data, and we can craft XML requests like this. We just set a transfer name and the content we want to transfer. Sending it to my backend, okay, it just responds with a status. Okay, here the transfer succeeded. So let's play the XXE attack. Okay, so you have to know that in XML you are able to define external entities that does not belong to the schema of your XML. To do such thing, open a doc type, define an entity with an arbitrary name. Here I've chosen file, and the system type of external entity. It exists several types, but we'll see only here the system one, with a path, as you can see. And see here that I'm also using a reference of this external entity as the transfer name. So what will happen? Just remember that in the response, the server send me back the name of my transfer. So it has in line the content of the file described by the path. And to show you, this is not an hard-coded behavior. I will change the path. Okay, so here I have the content of the current directory. If I can also change the path again. And what we just created, guys? Any idea? No? We have created the first remote file browser over XML over REST. That's a great feature, right? But that's a big security issue. So here we have to say, unfortunately, that's exploitable on my service, right? That's the end of the demo, right? Usually, security demo stops here, and you have to figure out yourself how to fix that. So no, I will help you. So here we have no luck. Usually, we have the version that fixes the problem in the description, as you can see here, okay? So it says here that we are affected if we are using Spring Data REST until the version 2.6.9, okay? But in this one, there is no information in the description. So what we can do, we can just click here on the CV ID, okay? Just to show you that we have the CVSS score on the right, okay? And this is really close to 10, meaning that this is a really critical issue, as you can imagine. But once again, we don't have much information. So we can click on the right here on the CVID again, and we will land to the National Vulnerability Database. And remember that at the end, we have the list of the impacted components with this version. So it seems that we are affected if we are using Jackson, including the version 2.7.3. So unfortunately, it's a field that is not mapped yet in the CV page of Dependency Track. So just to verify that we will fix the problem with the next version, which is the 2.7.4, this is the release note of Jackson. As you can see that they have done something here to disable by default the external entities. So let's try it. OK, I'm going to IntelliJ. OK, I will change the version of Jackson. I will restart my application. OK. Once again, because sometimes I don't care about the change. I don't know if there are any JetBrains engineer in the room. OK, so let's try the attack again. Problem fixed. So as you can see, we were able to find actual vulnerabilities in our systems through our dependencies, and we were able to mitigate them. So how it works behind the scene. So remember, I was talking about a tool named Dependency Check. So Dependency Check, So Dependency Check, you can install it as a Jenkins plugin. That's really easy. And then create a free form job, okay? In that job, the only thing you have to do, okay, is to invoke Dependency Check as a build step. Here, I set the path that will contain all the dependencies of my application, but that is not required. I only done that here because I was using an Uber jar. But if you are using Maven or if you are using NPM, it will automatically scan your pom.xml and your package.json to discover your dependency, okay? Okay. So what you can do also is to use the publish dependency check result post-build action. But the only thing it will do, it will publish a kind of little report like you can see here in Jenkins, but you won't be able to do such vulnerability management with that. That's read-only, okay? So that's why OWASP provides now Dependency Track, okay? So for Dependency Track, that's a standalone application. And Dependency Track provides a Docker image, okay? With those 3 lines, you are able to install Dependency Track on your machine. The only thing you have to do to know, is that by default it's using an H2 database, which is not required, which is not recommended to use in production. You should use a real SQL server, right? Okay. With that, you have Dependency Track up and running. So the first thing you have to do is to create a new project, okay, on which you will upload your report. Okay, so Devoxx, great. And then we want to connect Jenkins and Dependency Track. For that, we need an API token. So if you go to the administration tab here, on access management teams, you have user groups, okay, with special roles. And for the automation roles that comes by default is set for, to be able to interact with external tools. And here you can see there is an API key. You copy paste it, and you go back to Jenkins, okay? With the Dependency Track plugin, you just have to go to the global settings of Jenkins, okay? And at the end, we will have to set the path of dependency track with the API key. So now they can talk to each other. Last step, we are going back to our build, our analysis build, and we will ask Jenkins to upload the report on dependency track using the publish result to dependency track post-build action. So you choose your project, okay? And here you have to define the report name with the report type. That's because dependency track supports several analyzers, and here the Jenkins plugin is not able now to detect it automatically, right? And with that, you have built your first DevSecOps pipeline, and you're able to upload it to dependency track, okay? Some stuff I can show you as well is that it supports, like I said, NPM-based applications, okay? So you can see it here. So instead of relying on the NVD, it will rely on the NPM public advisory repository, as you can see here. That's not CVIDs, right? But that's basically working the same way. What dependency track is providing that Sonar is not providing is that it will automatically query once a day the NVD database to know if it has been reported new vulnerabilities. If so, it will update automatically the existing report without launching again everything, okay? And it can also notify Slack or Teams or other chat tools that you are using. One other interesting stuff is the component view. In the component view, you have the list of all the dependencies of all the application of your portfolio. If I'm taking this one, okay, so I have one dependency here, I can see all the project that is currently using it. And if, for example, I know that there is a vulnerability that is reporting on all those projects, and I want to flag it as not affected for all of them, you can click here on the audit mode, and then you will be able to flag it for all the portfolio at the same time, okay? Okay, so there is some dashboard here, okay? So that's pretty fun if you want to play with it, some kind of reports. And, sorry, I lost the focus. So this is the whole ecosystem that dependency track supports, okay? There are some tools here that are not open source, but maybe you know that already if you are using them. And so let's play with it. Thank you very much. That was all I got for this demonstration. I hope it has convinced you to move forward to DevSecOps. I would like to thank you as well, Axel Aigbede, who has made the picture of my talk, and you are able to get the retranscription of it on Medium. Thank you. Any questions? Okay, yes?
Can we do it through Jenkins file, or do we need always the GUI?
No, you can do it through Jenkins file. Other questions? Sorry, you have to shut out a bit louder because I cannot hear you. Okay. Okay. Yes?
Can we use just plugin without without UI, I mean web UI, to send the reports? Can we read it manually?
Yeah, so the dependency check report, you can read it through a CLI that is provided by dependency check, if it was your question.
But dependency check looks into all the database to fill the report and all the information that I need in the report. So in order to follow all, in order to compare different reports for different builds, I need a UI.
No, you don't really need a UI because you are able to also perform a vulnerability management directly with dependency check, but you have to craft some XML and stuff like that by hand, but it's not really, if it was your question.
Yes, yes.
Okay, yeah.
My question was if it's possible to reset the separation in dependency tracking after the POM file has been modified. Let's say, I mean, considering the example we
Yes.
that the vulnerability was in Spring data, we were not using it then. But if some developer introduces that dependency and uses it later on.
Okay, so the question is if so we saw that that we flagged as not affected one vulnerability because we were not using Spring Data REST. So is that possible to get it back once we are using it? So the thing is, that's feasible because you just have to click back on suppress, and it will be taken again into account, okay? But the thing is, you have to think about it. So if you are going there, it was not this one, sorry, this one. You click on suppress, now it will be taken back into account.
But that's a manual step, right? And if a developer does not do that.
But the thing is, how can you figure out that actually it's using it? Sorry, it's pretty easy because you are not directly importing Spring Data REST because it's not used by the application. If it's now used, it should be again reported, but not on the same jar. Okay. So here it will be detected. In fact, the report is not filled the right way because it is reported on a Spring Boot jar, which is not the right one. Okay, but let's imagine that in the same jar you have a part. Let's imagine a class that is not used, and you flag it as not affected. And someday the developer is using it. You have to do something manually. The real best practices you can have is to upgrade. That's the best thing you can do by default. If it's possible, you will save you a lot of time because it can be really hard to figure out if you are affected by the dependency, by the vulnerability. Here it was really easy. Sometimes that's really technical with stuff that you won't perhaps master. So by default, you should upgrade your dependencies. So this way, you won't have that kind of issue. But anyway, yes, you have to do something manually in that particular case. Yes?
For me, the suppress is usually the last step to do if you cannot fix it.
Sorry?
For me, the suppress is the last action because you cannot fix it. If you can fix it, we have to fix it.
Oh. Yes, but the thing is that if you're... Okay, yes. Yes, you can see it like that. But sometimes you can say that I will never use that. For example, Spring Data REST is very, in that case, is very special. If you don't want to export directly your repository in REST, you can say I won't be affected, and I can suppress it. Okay, last question.
Is it possible to get these misfiled CVEs fixed? Because if it would be on the component Spring Data REST, we wouldn't have the problem.
Oh. So yes, that's possible. So sometimes you will have false alarm. What you can do is to open a pull request to dependency check, and they will correct. In the past, we had some trouble with the database drivers. We had database vulnerabilities on the driver, but they have done some stuff to optimize it. So if you notice anything, you can open a pull request. Thank you very much.